All right, guys, I'm going to do question number 12. This is the example that Jessie created in her Christmas packet. I like this example because it's kind of real-world application here. The population of an endangered bird is decreasing, which is a very important thing to note. That means we're dealing with exponential decay. So we can immediately now, we know it's decay, so we can write down our decay formula. To the t power over n. Now, n is going to be 1 in this case. It was in all the examples you guys created, so it's really just to the t power. T divided by 1 is just t. It's decreasing at a rate of 0.75% per year. So our rate is 0.0075. Remember, that's 0.75%, so we still have to swing that decimal place over 2 spots if we want to put it into decimal form. There are currently about 200,000 of these birds, so the principal amount is 200,000. How many birds will there be in 100 years? We've got all the pieces we need. Let's plug them in. P is 200,000. 1 minus 0.0075 to the 100th power. All right, so that's really the same as 200,000 times 0.9925 to the 100th power. And all we have to do now is just evaluate this. We can plug this into our graphing calculator, or you can plug it into Wolfram Alpha if you go to that website, wolframalpha.com, and it acts like a super calculator. Just plug that into the search bar. So if we evaluate that, we will get 94,206 0.65. So about how many birds, whole birds, right? 0.65 of a bird doesn't really make any sense. So if we're dealing with 94,206.65, we have to round down to where there was a whole bird. All right, so about 94,206 birds will exist. All right, now that's the example that's very straightforward. We're solving for A. Now what I've done is kind of turned this problem over on its head. Instead of solving for A here, we're going to be solving for a different variable. So the bird population has been decreasing. It's been doing that for 45 years already. So now, in our formula, we know that the time is 45. It's been decreasing that whole time. The rate hasn't changed. It says it's at a rate of 0.75%. There are currently 200,000 of these birds. So the total amount is 200,000. How many were there when the population began decreasing? So we're going to solve for P here. So 200,000 is actually our A. P we don't know yet. We still have this 0.9925, but now it's to the 45th power instead. So let's evaluate that expression on the right-hand side. We have 0.9925 to the 45th power. That comes out to 0.7126, and we still have this 200,000 over here. So in order to get P by itself, we have to divide by 0.7126 on both sides. So if we do 200,000 divided by that number, we will get 280,644. So 280,644.67, and again, we can't have 0.67 of a bird, so P would equal 280,644 birds. So that's just the difference between solving for P and solving for A. And for each of these, the B version will be solving for P. So you'll get a little practice with both. So pick any 5 of these. There are 48 questions here to choose from. Any 5, that's all you have to do. So good luck. I'll see you guys tomorrow.